All right, last thing I'm going to talk about is the atomic weight or the atomic mass. They mean the same thing. I know weight and mass aren't the same thing, but if I say atomic weight or atomic mass, I'm referring to the same thing. That is the number that has decimals on the periodic table. Okay, not the whole number. The whole number is the atomic number. The one with decimals is the atomic weight or the atomic mass. Now, if mass numbers are whole numbers, why would the atomic weight have decimals? Well, that's because it's actually an average of all of the isotopes for a specific element. Okay, so it's a weighted average of all isotopes, okay, for an element. All right, its unit is going to be AMUs, or atomic mass units, just like the mass number. And we can actually calculate this. So the atomic weight or the atomic mass is, calculation is the percent abundance, meaning how much there is for an isotope, times the mass of an isotope, plus, you just keep going for each isotope, the percent abundance of the next isotope, I'm going to abbreviate, times the mass of the next isotope, plus, and so on and so forth, all divided by 100. That will give you the atomic mass, the weighted atomic mass, okay? So essentially you do this for each isotope. Add them all together, you will get the number that's on the periodic table. Okay, you will get a weighted average. So essentially what this type of average is doing, it's taking into account how many are carbon 12s, how many are carbon 13s, how many are carbon 14s. Okay, so if we have like 90-some% carbon 12, which is true, then the mass is actually going to be more weighted toward 12. That's why on the periodic table it's 12.011, is because actually almost all of carbon is carbon 12. Carbon 13 and carbon 14 do exist, and they're taken into account, but most is carbon 12, so it's a weighted average. Okay, so you're gonna have to do some calculations like this on the homework. So I'm gonna do this example. So as example, chlorine has 2 isotopes. You can be chlorine 35 or chlorine 37, meaning their mass numbers are 35 or 37. Chlorine has a mass of 34, or sorry, chlorine 35 has this mass. Okay, so I have this mass and an abundance of 75.78%. And then 37 has this mass and an abundance of 24.22%. What is the atomic weight? Okay, so I'm going to use my equation. Essentially, it's the first percent, 75.78, times the first mass, 34.969, plus the second percentage times the second mass. Okay, all divided by 100. Okay, now I want you to keep a couple things in mind here. First of all, your percentages should always add up to 100. If your percentages don't add up to 100, then you did something wrong when you were getting your data. Also, what was the other thing I wanted to say? You could change your percentages into decimals first instead of dividing by 100 at the end if you want to, it doesn't matter. But watch your order of operations. If you do your order of operations wrong, you're going to get an answer that doesn't make sense. So when you do this, and I recommend trying it right now in your calculator, you're going to get 35.46 atomic mass units. Okay, and that's actually correct for chlorine. It's really close to 35.46 on the periodic table. But this makes sense. So you should get an average somewhere in between 34.969 and 36.996. If you don't get a number between the actual atomic masses that I give you, then you did something wrong with your calculations. So usually when you do a math problem, at the end, I want you to pause and ask yourself, does this answer make sense? If, for example, I got 32 point something, that answer doesn't make sense. That must have meant that I did my algebra wrong. Okay, so always go back and make sure your answer makes sense. Mine does because it's in between my two numbers. So this must be the answer.